Now that we have understood the formulas of centroid for all the standard shapes, now let's understand the concept of finding the centroid of composite shapes. Students, there are two different formulas that we need to understand to find the centroid of composite shapes. So let's understand this with the help of a diagram. Suppose, students, I take the x-axis, the y-axis, and the z-axis. So there is x-axis, there is y-axis, and then there is z-axis. Now, I'm going to take a plane figure such that it is of very minute thickness, say t. So I have a plane figure here, and its thickness is, say, t. So this is a plane figure. Its thickness is taken as t. Now this t is very small. Students, further I have kept the entire plane figure in the xy plane. Getting or not, it is entirely kept in the xy plane. Now what I will do is I will divide this plane into small parts. Let's divide the plane into small parts, and then every part will have some weight, say W1, W2, W3, W4, and so on till I can say Wi. So I have divided the entire plane figure into small I number of parts. Every part has weight Wi. Now students, I can say centroid is nothing but the weight of the body acting at one particular point, isn't it? We have assumed here that the entire body is kept in a uniform gravitational field and the density of the body is also constant. So here I can say there is one point, say G, the centroid, where the entire weight of the body will get concentrated, isn't it? So let us say there is a point G where the entire weight of the body is getting concentrated. So let us say this is weight of the body W. So W is the weight of the body. Now W1, W2, W3, W4, and so on up to Wi. These are weights of small parts of the body. So they will all be again acting in the downward direction towards the center of gravity, isn't it? So there is this W1, there is W2, there is W3, there is W4, W5, and Wi. All these weights are trying to act in the downward direction. Now students, I can very easily say that the total weight of the body W is definitely equal to W1 plus W2 plus W3 and so on till Wi. I have divided the entire body into I number of elements. Every element has weight W1, W2, and so on up to Wi. All these weights are acting in the downward direction. Then the sum of all these weights must be equal to the weight of the entire body. Now students, if we recall something called as the Varignon's principle, it says that the sum of moments of all the forces acting about a moment center must be equal to the moment of the resultant force. Let's very quickly understand the statement one more time. I said the Varignon's principle or the Varignon's theorem says that the sum of moments of all the forces about a certain point is equal to the moment of the resultant force about the same point. So students, here I'm going to take, let us say, the resultant of all the forces about, say, the y-axis. Let us take the resultant of all the forces about the y-axis. So I'm going to take the moment of every single force about the y-axis. So can you say that every single force will be at certain distance, isn't it? So let us say this distance is xi. Wi will be at a distance of xi, likewise W4 will be at a distance of x4, W3 will be at a distance of x3, and so on. W1 will also be at a distance of x1. That means I can say the moment of all the forces, if I want to get, this is going to become equal to the moment of the first force W1, its distance is x1, so I can write W1 into x1. The moment of the second force, it is going to be W2 into x2, then W3 into x3, and so on. I can keep on continuing till Wi into xi. So this is nothing but the sum of moment of all the forces. Likewise, students, I can say moment of the resultant force. Moment of the resultant force, which is the resultant weight, W, isn't it? It is going to be the weight of the entire body into, I can write x bar, where x bar is nothing but what? It is the distance of the centroid, isn't it? Distance of the centroid. So the horizontal distance, or the distance which is parallel to the x-axis, or I can say the perpendicular distance from the y-axis, this is called as x bar, isn't it? So x bar multiplies with the weight of the body, I get W to x bar, and then I can say from the Varignon's principle, from the Varignon's principle, I can write that sum of moments of all the forces is equal to the moment of the resultant force. I have taken the moment about the y-axis here. So W into x bar must be equal to W1 into x1 plus W2 into x2 and so on, plus Wi into xi. So from here, can I tell that x bar is going to be equal to what? So x bar becomes equal to W1 x1 plus W2 x2 plus dot 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 till Wi xi upon the denominator is going to be W, but I know W is nothing but what? It is W1 plus W2 and so on up to Wi. So I can write here W1 plus W2 plus W3 plus dot 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 plus Wi. So that's x bar, students, isn't it? That's x bar. So similarly, if I want to write for y bar, what would be the formula for y bar? I can similarly write the value of y bar. Y bar is going to be W1 into y1 plus W2 into y2 and so on. I can keep on adding till Wi into yi whole divided by W1 plus W2 and so on till Wi. Here y1, y2, y3 are nothing but what? They are the distances of the weights W1, W2 and so on from the x-axis, isn't it? And what would be y bar, students? So y bar is going to be the distance of the centroid from the x-axis, isn't it? So this distance here, the distance of the centroid from the x-axis is going to be y bar. So now I've got x bar and y bar. So can I say that x bar can simply be written as, students, x bar can simply be written as summation of Wi into xi upon summation of Wi, isn't it? Summation of W1, or I can say summation of Wi into xi upon summation of Wi, which is nothing but what? W1 x1 plus W2 x2 and so on up to Wi xi upon W1 plus W2 up to Wi. Similarly, students, what could be the value of y bar? So y bar can be written as summation of Wi into yi upon summation of Wi. Now, I have got the values of x bar and y bar in terms of the weights of the body, isn't it? Wi is nothing but what? It is the sum of the weights of all the small particles of the body. Now I'm going to get the same formula in terms of area. So let's try and understand how to get the formula in terms of area. Now, students, don't you recall that weight of the body? Weight of the body is nothing but mass of the body into the gravitational constant g, isn't it? Mass of the body into the gravitational constant g. When you take the product of these two terms, you get the weight of the body. Further, can you say mass? Mass of the body is nothing but the density of the body into the volume of the body, and this multiplies with g, isn't it? The gravitational constant. And finally, students, now I can say that volume is nothing but what? It is the area of the base into the perpendicular height, isn't it? So I can write here density into volume can be written as area of the base into the perpendicular height. This multiplies with the gravitational constant g. Now students, haven't I told that for all the particles which are present over here, density is uniform. We are taking density constant. It is a uniform or a homogeneous material. That means the density will remain constant for all the particles over here. So I can say density can be written as rho, isn't it? Multiply by area. Now every single particle, every single part over here that I've considered, every single part will have a different area, isn't it? Every part has a different area. So I can say it's A1, A2, A3 and so on. So in general, I can write AI. So I'm going to write here AI into students the height. Now the height is nothing but what? It is a thickness, and every single part over here again has the same height, the same perpendicular thickness. So T is the thickness that I've taken. So I'm going to write here T, and this multiplies with G. So that's the formula for the weight. So students, here I can say Wi becomes what? Wi becomes rho into AI, T and G. So I'll be getting here X bar becomes equal to summation of rho into AI into T into G. That's the replacement of Wi into Xi. This whole divided by summation of again Wi we have. So it is rho into AI into T into G. So you can easily observe from the summation this rho, T and G, these terms can be taken outside the summation, isn't it? They are constant for all the terms. So rho, T and G can be taken outside the summation. So now you get X bar as what? It becomes summation of AI into Xi upon summation of AI. You can very easily understand that rho, T and G from the numerator and the denominator can be cancelled. So you get X bar as what? Summation of AI Xi upon summation of AI. So similarly students, if I want to write Y bar, what would be the formula for Y bar now? So Y bar becomes equal to summation of AI into Yi upon summation of AI. So students, we need to remember the formulas in terms of the areas. We are going to solve many questions of finding the centroid of plane figures of composite shapes, and every single time we are going to consider the areas. If you recall, we have seen all the formulas for the standard shapes in terms of areas, isn't it? So that's why I'm going to write X bar now. X bar is going to be summation of AI into Xi upon summation of AI, and students Y bar is going to be summation of AI into Yi upon summation of AI. These are the two formulas for finding the centroid of a composite body. So if you have a composite body, that means it is nothing but what? It is made out of different standard shapes. You take standard shapes, you combine them, you will get a composite body. So if I want to find the centroid of a composite body, then the formula that I'll be using is X bar is equal to summation of AI Xi upon summation of AI, and Y bar is going to be summation of AI Yi upon summation of AI. Xi and Yi are nothing but what? They are the centroids of the individual areas. That means that the perpendicular distances of the centroids of individual areas from the x-axis and from the y-axis. So when I say Xi, it is from the y-axis. When I say Yi, it is a distance from the x-axis. So students, now we have understood how to get the centroid of a composite shape. Now remember that this particular derivation that I've shown might not be expected in the exam, but students, we should definitely know how the derivations are to be proved. So we have seen here the formulas for X bar and Y bar. Now we are in a position to start with some questions. So students, let's begin ahead with some questions.